This presentation provides an overview to help understanding of the evidence and ideas of polycrisis. A crisis is a sudden non-linear event or series of events that harms, in a short time, the well-being of many people. Polycrisis can be defined as crises in multiple systems becoming entangled, degrading humanity's prospects. Together, these crises produce harms greater than the sum of each alone because their host systems are deeply interconnected. Civil Nexus is a platform for individuals and teams working on appropriate civil society responses to polycrisis. It promotes capabilities for autonomy and self-reliance of polycrisis response initiatives within a supportive, like-minded community of civil society organisations. It provides tools for people to act, not just out of fear of our uncertain common future, but for concern at what we have lost and hope that we might ease the coming societal transitions. You're looking at a configured version of the Sparks Enterprise Architect, Sparks EA, GUI interface for desktop and internet collaboration. Sparks EA maintains a linked and consistent database reflecting concise and precise diagrams of elements and linkages for model-based systems engineering, MBSE. Sparks EA is a comprehensive tool for iterative consultation, capability building, planning, development, delivery, operation, and review of systems and initiatives. Integrating capability building presentations material directly into the Civil Nexus GUI and platform minimises presentation work duplication. Materials in this presentation from public reports are published under the Creative Commons licensing terms of those reports. Model-derived diagrams and underlying model are copyright Civil Nexus. The most important measured planetary health indicators have overshot safe planetary boundaries. Global consumer industrial society has already triggered a period of danger and instability for Earth systems and society functioning. Even if our societies urgently cease applying crisis-forcing stressors and triggers, the momentum of Earth systems will carry on the danger and instability, probably for centuries. Humanity has entered a period of collapse. Civil society can act with urgency to reduce the severity and duration of the collapse and mitigate its impacts. Planetary health at a glance. Just as a blood test provides insights into a human body's health and identifies areas of concern, this planetary health check evaluates the 13 measured control variables across the 9 planetary boundary processes to report on Earth's stability, resilience, and life support functions, the overall health of our planet. The 2025 assessment shows that 7 of the 9 PBs have been breached. Climate change, change in biosphere integrity, land systems change, freshwater change, modification of biogeochemical flows, introduction of novel entities, and ocean acidification. All of these show increasing trends, suggesting a further deterioration in the near future. 2 PB processes remain within the safe operating space. Increase in atmospheric aerosol loading, improving global trend, and stratospheric ozone depletion, currently stable. Figure 6 of the Planetary Boundaries Health Check shows the great acceleration, recent dramatic trends in the Earth system. This updated figure extends the original Great Acceleration analysis by Stefan et al. With new data up to 2024, incorporating new datasets and in some cases revised or additional indicators. The top section shows the exponential growth in socio-economic drivers such as population, GDP, and energy use. The bottom section illustrates corresponding Earth system responses, including atmospheric CO2 levels, global temperatures, ocean acidification, and biodiversity decline. These coupled trends, which accelerated markedly after 1950, signify the onset of the Anthropocene and highlight the intensifying pressure humans place on planetary systems. Updating these trajectories reinforces the urgency of remaining within the planetary boundaries to safeguard Earth's resilience. Although a few indicators, such as marine fish capture, domesticated land, and stratospheric ozone depletion, show signs of flattening or recovery, most trends continue to rise steeply, underscoring the intensifying human pressure on planetary systems. These coupled trajectories define the post-1950 onset of the Anthropocene and reinforce the urgency of respecting the planetary boundaries to protect Earth's resilience. From the IP-based Nexus Assessment 2025, figure SPM3A shows impacts of trends in indirect drivers on trends in direct drivers of Nexus elements. Figure B shows impacts of trends in indirect drivers on the Nexus elements themselves. Figure A shows annual growth for selected indicators of indirect drivers and the impact of those on the trends of direct drivers. For the given period of time, trends of indirect drivers intensified direct drivers and thus intensified climate change as one of the Nexus elements. To provide a comprehensive picture of the Nexus, climate change is duplicated because it is both a driver in figure A and a Nexus element in figure B. An analysis of the same indirect driver trends in figure B was used to assess the impact of these trends on the Nexus elements: biodiversity, water, both availability and quality, food, both quantity and quality, and health, both physical and mental. This figure summarizes knowledge on recent trends over the period 2001 to 2021 according to data availability. For both figures A and B, if knowledge is inconclusive, no impact score is given. The abbreviations GDP for Gross Domestic Product and ICT for Information and Communication Technologies are used. Because polycrises are interlinked in complex ways, positive and negative feedbacks can lead to runaway instability. Tightly linked systems with multiple feedbacks exhibit behaviours which are problematic for planning, governance, and operation of modern societies. The system behaviours include volatility, uncertainty, novelty, complexity, turbulence, and ambiguity. Functor. The diagram shows a basic model of systemic crisis. In figure 4A, stresses interact with a trigger in a single system to generate a crisis. The multiplication sign indicates that stresses and trigger are both causally necessary for the crisis outcome and that the trigger multiplies the impact of the underlying stresses. Figure 4B represents the above process using a stability landscape, which is a visual metaphor depicting stability and change in complex systems. The horizontal axis represents the range of possible system states defined by different values of the system's core state variables. It condenses figuratively an n-dimensional state space into one dimension. The vertical axis represents the degree of system stability. Lower positions denote greater stability and therefore greater probability than higher ones. The ball represents the system's state, the values of its core state variables at a particular moment in time. The ball tends to roll downwards towards higher probability states, as if drawn by gravity towards greater stability, into a basin of attraction. But the ball never entirely settles at the bottom of its basin. Instead, it is constantly jostled within the basin by the system's internal processes and by perturbations from its surrounding environment. Each basin represents a dynamic equilibrium, a set of feedbacks and relationships that constrain the system's behaviours and provide long-term stability amidst its short-term fluctuations. Together, the basins keep the system state in bounded regions of the full landscape. A critical transition, also known as a regime shift, occurs when a perturbation pushes the system from an established equilibrium into a different one that encompasses a different set of system states and behaviours. Once a system is forced out of equilibrium, it may move into a different basin and therefore complete a critical transition. It may return to its original equilibrium if antecedent conditions are restored, or it may move around the landscape without settling. The latter situation constitutes a systemic crisis, an incomplete critical transition in which the system has left one basin of attraction but has not yet settled into another, and thus remains in a highly unstable and potentially harmful state. The figure illustrates how system stresses can act to make a basin of attraction shallower so that a trigger event can move more easily, push the system out of equilibrium. The diagram shows crisis interactions between multiple systems. Figure 6a shows common stresses. The same stress, indicated by the green boxes, may affect two or more systems. An ageing population, for example, places additional demands on healthcare systems. It also strains the economy by diminishing the workforce while increasing government spending on healthcare and social welfare. Figure 6b shows common triggers. The same trigger, indicated by the green boxes, may interact with stresses in several systems to produce multiple crises. Russia's invasion of Ukraine and the sanctions imposed in response, for example, triggered a crisis in the energy system and in the food system. Figure 6c shows interacting stresses. A stress in one system may causally interact with a stress in a second system, which could then affect the stress in the first system, as indicated by the blue arrow denoting a causal relationship. Food insecurity, for example, forces the poor to devote a major portion of their income to their alimentary needs rather than their education, investment, and enterprise. The result is greater poverty and inequality in the economic system, which may then lower incomes and worsen food insecurity for the most vulnerable segments of society. Figure 6d shows intersystemic stress trigger interactions. A stress in one system may generate a trigger event in another system. By disrupting habitats, for example, climate heating in the Earth system increases the zone of contact between humans and unfamiliar animal species, which increases the likelihood of a zoonotic, that is to say animal to human, viral transfer that triggers a pandemic. Figure 6e shows crisis impacts on adjacent systems. A crisis in one system may causally affect the stresses or trigger events of another system. The COVID-19 pandemic, for example, deepened the stress of socio-economic inequality, while aggressive fiscal responses by governments triggered inflation. Figure 6f shows intersystemic crisis interactions. A crisis in one system may causally interact with a crisis in another system, altering the dynamics of each. An international security crisis, for example, can worsen the climate crisis by diverting urgently needed attention and resources from climate action, while the climate crisis can intensify an international security crisis by escalating conflict over resources and propelling mass migration. Polycrisis researchers identify three key principles for addressing polycrisis. Principle 1, focus on crisis interactions, not isolated crises. Governments tend to focus on individual and immediate threats, which often renders their management of systemic risks ineffective. Because today's crises are causally entangled, they can be neither fully understood nor addressed in isolation from one another. A comprehensive approach is necessary. An integrated assessment of the full range of interlinked crises involved, especially when policies that address one crisis might worsen or undermine efforts to resolve others. Principle 2, Address system architectures, not just events. The polycrisis concept also highlights the role of densely interconnected global systems as the conduits that transmit the causes and effects of cascading crises. Policymakers must work to change system structures that generate such hazards. They can, for instance, strengthen negative or dampening feedbacks that counteract pernicious positive feedbacks. In some cases, they might reduce connectivity or create buffers or fire breaks at sites of systemic vulnerability. Recent efforts to more heavily regulate financial institutions designated as systemically important show that governments and international agencies are starting to internalize this principle. But much more can be done to protect technological infrastructure by increasing the resilience of vital communication systems to electrical, grid, and satellite failures, for instance, strengthening food systems by buffering against the risk of simultaneous breadbasket failures, and reduce pandemics arising from zoonotic spillover by limiting wet markets, bushmeat consumption, and the illegal wildlife trade. Broadly speaking, policymakers should consider resilience alongside efficiency when evaluating policy outcomes, which means encouraging policy diversity, experimentation, and redundancy, all elements of adaptive management. Principle 3, exploit high leverage intervention points. Many of the same features of complex systems that create polycrises are also provided opportunities for systemic transformations toward more desirable futures. When systems are prone to nonlinearities, positive feedbacks, and critical transitions, a relatively small action may have a profound effect if it is tailored to the system features. Network-based polycrisis visualization and analysis can help identify such intervention points. Civil Nexus builds entities and traceability into a dynamic model-based systems engineering, or MBSE, platform to enable agile research, analysis, planning, and effective action. If you found the presentation interesting and enjoyable, comment and like the presentation and subscribe to the channel. We appreciate constructive comments and suggestions. What are we doing right? What should we do better or more? What should we change or do less? You'll find new presentations in different aspects of the Civil Nexus platform as they are posted. If you're interested in exploring the Civil Nexus platform, contact us via the comments to request access to a personal use read-only copy of the repository that you can virus scan and browse on your desktop. You'll need to visit the Spark Systems website to download and install the free Spark Systems EA Reader to access the models. If you're interested in collaborating on the platform for initiatives to address polycrisis, contact us via the comments to request edit permissions and access. We're interested to make your polycrisis mitigation initiatives of civil society groups visible to others. We can facilitate video conferences to help you document and link your initiatives and stakeholders in the Civil Nexus platform. We can provide basic written advice on configuring software, system, and platform connections. The platform tools are mostly free and open source software, or FOSS, suitable for Windows and Linux computers. But the editing-enabled versions of Spark's Enterprise Architect are a commercial product with a range of pricing and capability options. Even if you're not interested in Civil Nexus, get involved with civil society organisations interested in big picture solutions to polycrisis mitigation and adaptation. Continue hoping that BAU multilateral coordination will provide adaptation for polycrisis. Multilateralism is opposed by autocrats, well-funded private industry groups, and their captured legislators, regulators, and jurists. Progress on achieving required outcomes needs to happen 5 times faster than current rates to avoid the deepest societal collapses.